All right, I want to welcome all of you to Hononegah High School, Algebra 1. We're going to start off the year here in section 1.1. The warm-up today is a little bit of order of operations, just reminding you of some things, especially with dealing with signed numbers. So 5 plus a negative 15. You may want to think about this as 5 minus. Anytime the signs are different, it was a minus sign. So 5 minus 15 would be negative 10. 6 minus 7, negative 1. Anytime you're multiplying by a negative times a negative, or a negative divided by a negative would be a positive, but a positive times a negative, so negative 10. Negative 30 divided by 2 is negative 15. Multiplying by 0 is always 0. And then again, if you have two signs, both of them minus, so 4 minus a negative, minusing the negative is the same as addition. So I changed that into a plus sign, and then 4 plus 5 is 9. So again, a little bit of warm up here on some signed numbers. And now let's get into the actual section 1.1. So starting off the year. A little bit of vocab, an equation. So what is an equation? An equation is two expressions that are equal. So if I have one side equaling another side, they're two expressions, and therefore they're equal. Now, equivalent equations are two equations. So now we're talking about two different equations. So two equations that have the same answer. And then what's more important is the inverse operations. Inverse operations, basically, when you think inverse, you think opposite. So inverse operations, addition, the inverse then would be subtraction. If I had multiplication, the inverse would be division. So again, an inverse operation. There are many inverse operations as you go through different courses in mathematics. For instance, a square and a square root is an inverse operation. So here we go. We're going to talk about solving the addition property of equality. What the addition property of equality says is you can add the same number to both sides of an equation. For example, if I had A plus B, I could add C to both sides of the equation, and the equation would stay balanced. Subtraction is the same way. If I had an equation, I could subtract to both sides of an equation, and the equation would stay balanced. So we're going to use that property to solve equations. So if I have a letter, x minus 3 equals negative 5, I want to get rid of the minus 3. So in order to get rid of the minus 3, I'm going to add 3 to both sides. That will eliminate the minus 3, and now I'm just dealing with signed numbers. Negative 5 plus 3 is negative 2. Next one, same thing, just dealing with decimals. And yes, you are allowed a calculator. I know how sometimes in middle school you sometimes are not allowed a calculator. You are allowed a calculator, so if you want to grab a calculator, you can. 0.9 minus 2.8 is negative 1.9. So the last two, go ahead and try those two on your own. Hit pause for a second. And I'm back, and we're going to work on this. So I'm going to subtract 3 from both sides. Hopefully when you did these two on your own, you got negative 10. Fractions, I'm going to add 1/3 to both sides. Negative 2/3 plus 1/3 is negative 1/3. So again, don't be alarmed by fractions, and you can use a calculator in this class. So again, you are allowed to use a calculator if you are what I call fractionally challenged. Next, multiplication, same situation. You can multiply each side of an equation as long as you are not multiplying by something that is not 0. So you can't multiply both sides by 0. That doesn't work. But if I had an equation, I'm allowed to multiply both sides of an equation by any number other than 0. And the next one, if I had an equation, I'm allowed to divide both sides of an equation, and again, anything except 0. So now I'm looking at this first one. I'm going to multiply both sides. It's a fraction. So I'm going to multiply both sides by what they were dividing by. Since it was dividing by a negative 5, I'm going to multiply by a negative 5. Negative 3 times negative 5 is positive 15. I could technically divide or multiply by anything. So now I'm going to divide both sides by pi. It's pi times x. So I'm going to divide both sides by pi to get x by itself. And so negative 2 pi divided by pi is just negative 2. So 1.3 times z I'm going to divide by 1.3 because that is the inverse operation to multiplication would be division. So I'm going to divide both sides by 1.3, and I'm going to get 4. Now, it does say, and I know I didn't do this before, to check your answer, meaning if I plugged in 15 back into the original question here in A, negative 15 divided by 5, would it equal negative 3? So again, show your work, check your answers, okay? Make sure that you're doing it correct and getting the correct solution. Never leave a question with them two signs next to each other. If I ever see a minus, a negative, just like I did in the warm-up section, I'm going to rewrite it as a plus. Now this is a situation that most of you will get correct. You are going to subtract 3, the inverse operation to addition. And so then x equals 4. You're going to subtract a fraction. Do not be alarmed. It is a fraction. Fractions won't hurt you. 3/4 minus 7/4 is negative 4/4, or just negative 1. So now the next section, go ahead and pause the video. Try these two on your own, and I will wait. And we're back. So notice it's dividing by a negative 3. Many times I prefer it written this way. So instead of writing divided by negative 3, I write it as a fraction. So I'm going to multiply both sides by the inverse. So instead of inverse operation, so instead of dividing by negative 3, I'm going to multiply both sides by negative 3. 6 times negative 3 is negative 18. Again, I don't like having two signs. A plus and a minus is the same as it is subtraction. I'm going to add 2 to both sides, the inverse operation, and 5 plus 2 would be 7. Again, you can always check your answer to make sure if you want to plug 7 back into this question. 7 plus a negative 2 equals 5, and it is correct. Word problems. Do not be alarmed by word problems. They're merely questions that have words. Okay? In 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed. Now, many of you need to understand that distance equals rate times time. So in this particular question, we're going a distance of 200 meters. The rate is what we are trying to find. How fast was Usain Bolt going? And 19.32 seconds. So now you're going to pull out a calculator because we're not expecting you to do this in your head. You're going to divide both sides by 19.32 and get the rate at which Usain Bolt was running. 10.35 meters per second. Now, little add-on question here. Go ahead and read it. Hit pause, and I'll get back to you in just a second. And I'm back. So now, I realize it's just merely doubling, so many people are going to get the answer kind of logically, but let's say they ran something other than 400, you would have to actually do it this way. So again, distance, we're going 400 meters this time. We know the rate. So we are keeping the same rate as what we ran the other. Okay, so the average speed, keeping the same average speed. We want to know how long would it take him. So again, we're going to divide both sides. So 400 divided by 10.35, and you get 38.64 seconds. Now, some of you are going to say, well, that's just double what he did previously. And yes, because he's going twice as far. So again, this particular question probably didn't lead to you could actually just done it logically speaking. But again, distance equals rate times time is a normal equation that you might have to use throughout your algebra career. Discounted concert tickets is $14.50 less than the original price. So we're going to write an equation. The price plus $14.50. Sorry, let's try this again. The price minus $14.50 equals $53. So now the original price minus $14.50, that's how much you're taking off the original price, is equal to $53. Adding $14.50 to both sides, $67.50. Sorry about the pause there, I was interrupted. So price minus $14.50 equals 53. I'll read the question one more time. The discounted concert ticket of $14.50 less than the original price. You pay $53 for the discounted ticket. What is the original price? The original price of the ticket was $67.50. A little bit of closure here. Describe in words how you would solve a one-step equation. The key word when you are describing a one-step equation is inverse operation. So if the variable has a addition, something's being added with the variable, you're going to subtract then. If something's being multiplied with the variable, you're going to divide. So again, inverse operation would be the best way to describe And then the last one, are these equivalent? Yes. Now, normally they are not written this way. But yes, technically speaking, they are all equivalent. A negative n over 5 is equivalent to a negative n over 5, which is also equivalent to n divided by negative 5. And again, this one might get a little bit of an asterisk, only because that is not how most people would want it written. And again, most people would write it in one of the first two methods, but technically speaking, they are all equivalent. You have a homework assignment that is written on the front slide. If you have any questions, make sure you talk to your teacher, and good luck and welcome to Algebra 1.